So we have a question here. This is very easy question. So there's a lot of approach you can do it, but personally, I'll just do this by using integration by parts. Okay. So first I write my formula. Formula say integral u dv equal to uv, and then you change u dv, and then here flip it, say v du. Okay. Okay, so that's my formula. So I'm gonna have to separate. So I'll separate. I'll say integral. So instead of say sec cube, I'll say sec x, and then I'll say sec square x. So this is gonna be u. This is gonna be dv. U and dv. Now right there. So I'm gonna let u equal to sec x, and the dv equal to sec square. Okay, so what I'm gonna do, I'll differentiate sec. When you differentiate sec, you get du, and when you differentiate sec, it's gonna give you sec tan dx. Now you come and integrate this. Okay, so for this one here, we integrate. So when you integrate dv, so you can say integral and integral. When you do integrate dv, you get v. Why we do that? We integrate this and you integrate that one. When you integrate v, dv, you get v, and then when you integrate sec square, this is going to give you tan of x. So then the next step, we're going to come and substitute back. So integral of u dv is same as say this, is same as say this. So u dv is same as say integral of sec cube u times v. This on that. So sec x tan x. Okay, and then we go v. This is our v here, tan of x, and the times du. What is the du? Our du equal to sec x tan x. So sec x tan x, if I plug it in here, these tan, they're going to be two of them, so it's going to be tan squared. Look, tan is going to come in, it's going to be tan squared. So we let you sec x dx. Sec x dx. See? So what I'm going to do, I'll replace these. What is tan squared? Tan squared equal to sec squared minus 1. So I'm going to say, this let me say integral sec cube x dx equal to sec x tan x integral, this let me say sec squared minus 1. And this equal to sec x. So for some people who know, look, how do I know tan x squared equal to sec squared minus 1? From the trig. Look, we know from the trig identity, sine square of x plus cos square of angle equal to 1. So if I want to create what is the meaning of tan square, how do you get tan here? If I want to get tan, means I have to divide by cos in the sine. Means I have to divide by cos square, divide by cos square throughout. Look, sine divided by cos equal to tan. This is going to be 1, and then this is going to be sec square. So can't you see? If you want to replace tan square equal to sec square minus 1. That's say sec square minus 1. So we multiply this out. When you multiply that out, it's going to be sec cube and sec. So multiply that out. This is going to be sec cube and sec. So it's going to be, okay. So I'm going to raise, and then say this. Say sec cube minus sec dx. And then you can multiply this out. This is going to be negative sec cube. So I can remove this, and this is going to be plus. Or let me just go step by step. Okay. So this let me say sec x tan x, and then minus, okay, this is going to be, we can separate, say integral of sec cube x, this is going to be plus integral of sec x dx. And the next thing, okay, so now then, here we have integral of sec cube x dx. So what I'm going to do, when you integrate, okay, so look, so this is equal. This is sec cube x and this is sec cube x. I will just literally take this on to the left hand side. So because they are equal, same thing, sec cube x. So I can take this over the equal sign. So since this is negative, when you go over the equal sign, it's going to become positive. So they're going to be two of them. So let me say integral of sec cube x plus another, because this is going to be plus integral of sec cube. So they're going to be two of them. So equal to sec tan x, sec x tan x. Okay, and then here I'm left with plus integral of sec. But when you integrate sec, we know we're going to get, when you integrate sec, you get ln sec tan. So this is going to give us ln sec tan, sec x plus tan x, absolute. So what you do, divide by 2 throughout. And I'm going to show you how did that came about. I'll show you now. How did you get these to that? So now divide by 2 here. Divide by 2. Or you can just put one line. You can say divide by 2 separately. So this in this concept. So integral of sec cube x dx. Same as say a half sec x tan x. Plus another half. Or you can just literally write one line and then write over 2. Or you can say a half ln sec x plus tan x plus constant because we don't have no limit. So the question is, how did I know this integral of sec x equal to ln sec x tan x? I can show you quick, but this question has already been solved. But I'll just show you so you can have a understanding how you solve. Okay, so you want to see how integral of sec it gives us ln of sec tan x. Let me show you. So integral of sec dx. So what I'm going to do, I'm going to introduce something next week. So this MSA integral, so this I'm going to write my sec exactly, and then I'm going to introduce here sec tan. Look, I'm going to introduce here tan plus sec. It's just something I'm introducing. But whatever I'm going to introduce on top, I must introduce the same thing as the denominator. So that's not going to make any changes. Okay, tan plus sec. So can't you see, if you, like if somebody give a over is like a 1, so it's like, I didn't make any changes, it's just something introduced and it can be cancelled one another. So what I'm going to do, I'm going to multiply this out, so this is an integral sec tan x multiply plus sec squared dx over tan x sec x plus sec x. So I'm going to let u equal to this one right here, sec x plus tan x plus sec x, and that will differentiate because I know this is going to be substitution. When you differentiate u, is going to give you the u. When you differentiate tan, it gives you sec squared, and then when you differentiate sec x, it gives you sec x tan x, but with respect to dx. But this one here is this one right here. Can't you see? So all this stuff on top is going to be du, so we can substitute. So this question here is going to become, I can write here, integral. This all is going to become du. And all this stuff at the denominator, we did let equal to u, so this will become u. So this time we say ln of u. But what is our u? We can place back. The u we did let equal to tan x sec x. So same we say ln of absolute, because whenever you have a ln, it's good to put absolute. Ln of tan x sec x, because that's what we did let u at face place. So sec x plus tan x plus constant. Why? Because there is no limit. That's why at face, when I did integrate sec x from there at the bottom, I say, oh, sec x equal to that. It was equal to this one. So that's how you knew, that's how I knew, and that's how you can learn from me. So if you face time, make sure you subscribe to this platform and share this video to a lot of people, because it might not be useful to you, but it might be helpful to other people. So thanks a lot for your time, and don't forget to donate. Okay, like I always say, you got $1, $2, $5, 50, 100. Don't fear shame. You can donate. People not gonna think like, oh, why did he do that? Oh, I'm shy. Why did I donate to this guy? 100 rand or $100 or $200. Don't afraid. See, even if you have like $250,000, you can just put it in. See, and that's gonna be a good example for the other people. Thanks a lot. Peace out. Bye bye.